Hi, I'm Dan Pursuit, and I'm joined with two of my colleagues, Dr. Joseph Kursky and Kathy Capelli. And today we're going to talk to you about our careers and how we've been able to leverage GIS technology to organize big and complex data, analyze it across time and space in context with other information, and easily share those findings. These skills are becoming more and more necessary for every scientific discipline, especially the ones that we see here at HEU. Each of us are going to give our own personal perspective on the use of GIS. And then we're going to turn to a panel discussion before opening it up to you for questions and answers. So to start off, I thought that I would talk a little bit about my career and how data and data analysis and GIS have kind of woven its way slowly through my career. First, I started off studying coral reef ecology. And back then, I look back at what we were doing, and it was primed for a GIS, right? We were conducting studies underwater with GPS points and mapping, trying to understand the locations of different species and how they were interacting with each other. But we did this with pencil and paper instead of in a digital way. Later, I moved down the coast and was doing similar things in coastal ecology, in marshes and seagrass beds. Later, I moved to doing restorative ecology, engineering the restoration of the Florida Everglades. And I definitely saw a lot of GIS becoming infused into these projects, but was still kind of sitting in the background, having never taken my class. And, I think back then I looked at the complexity of GIS, and it was always something that kind of scared me. That I never really wanted to get into because I wasn't taking formal classes of it, and I didn't really even know how to start and integrate that into my career. I moved after that to Washington, D.C. to work at NOAA, where I worked with satellite data, big data, climate data, model data, weather data, in situ monitoring data, and trying to bring all of these things together into a higher level understanding. And that's fundamentally what we try to do with GIS. So about at that same time, GIS started to take a little bit of a pivot away from just, here's something that you do on your desktop. And now it is sharing through the internet, collaborating with other people, new software platforms, more advanced capabilities. And that's when I had that kind of aha moment that, oh, wow, this isn't my father's GIS anymore. This is something that I can work with and can really start to leverage in the types of work that I do. And so that was a turning point that eventually brought me now to Esri, where I work with open data, trying to bring together groups of different people from academia, from research, from federal agencies and nonprofits to share our data in a common platform so that we can all leverage the good work that we're doing and advance science. So with that, I want to give you an example of how that jumpstart is happening. I work in what's called the Living Atlas of the World. And that is a community of contribution of data, over 8,500 different layers and maps, data layers that can be used for analysis or simple visualization or integrated into applications. I like to say it allows you to jumpstart your analysis or any of your workflows because you can start where others have left off. And a perfect example of this is this app that we developed in just a couple days of work earlier this year. And this is all using information in Living Atlas that was shared. So the EPA has shared their air quality information for the United States. NOAA has shared their forecast models. And Census, the Census Bureau, has shared all sorts of rich demographics. And because they work seamlessly in the ArcGIS platform, we've been able to integrate them really easily into a single app in which you can take something like air quality and see the multi-facets of air quality across the nation. The other thing that I do a lot, besides trying to develop this community of collaboration and data sharing is working in spatial analysis, both especially in climate, but also weather and land processes. So, for example, one of the things that really excites me about the ability to use GIS is I can do an analysis of really big data, complex data, and it only takes a matter of hours to do something that would take weeks before. So here's 20 some years of global satellite fire detections, and we're not just looking at the locations of the data. We're looking at spatial trends of the data right now. So if I click on one of these areas here in sub-Saharan Africa, we can see, or here in South Asia, we can see that there's actual values here in this map. This map isn't just pixels of color. There's actual values here, and that we can see the number of wildfires that have occurred in an area, and then apply our statistical analysis tools to it and see if there's trends. So if we see areas where there's an orange ring, there is a statistically significant trend in that area. Blue is a statistically significant downward trend in that area. And this type of analysis, again, over millions and millions of points over decades of data, was able to run in a matter of minutes. And that's kind of really what I say, kind of exemplifies how GIS has changed. And now I share this out with the rest of the world, and you can have access to this map, and then take this map and start to do a deeper analysis with it. So that's what I find really exciting about this. So that's kind of my perspective of GIS for somebody who isn't a GIS expert, who's kind of slowly learning it and integrating it into the science disciplines that I'm interested in. So now I'm going to turn it over to my colleague Joseph, who is one of the consummate GIS experts, and he's going to be able to give his perspective.
Thank you, Dan. Greetings all. Joseph Kursky here on the ESRI education team. I love Dan's final statements because it exemplifies what I'm mainly interested in, and that is lifelong learning, and which we encourage you folks at AGU to do. With geotechnologies, it's a fast-changing world, but we have a set of tools and a community that can help you in your own journey forward. And let's face it, all of the issues on our planet, climate, water, ecoregion, health, ocean acidification, et cetera, they're interdisciplinary, right? They're complex, and they're solvable because they have a where component. They show patterns, relationships, and trends. And that's why the three of us today on this panel are really excited to talk with you about geotechnologies. We really believe that they can enable a more resilient, healthier, happier future. So I salute your interest in geotechnologies. This tool is going to be incredibly relevant going forward in our society and also in your own future. Indeed, our ESRI theme at AGU this year is Next Generation Science Entails Where. Where. Perfect. Now, all of these challenges entail a where component. Now, why should you listen to me? Let me share my own career path briefly with you all. I share this not to bore you to tears, but because I want you to think about your own pathway forward. Now, as a child, I loved several things, chiefly getting outside and making maps. I actually drew big maps on poster board. They were my own made-up cities and ecoregions with colored pencil. My experience has been in 4 sectors of society. Nonprofit, so for example, National Council for Geographic Education, government, NOAA. I wasn't there at the same time Dan was, but NOAA, U.S. Census Bureau, and U.S. Geological Survey. Also academia and private industry with ESRI. So I share that because of a couple reasons. Your own path can change over time, as mine has, and it can incorporate multiple elements. So for example, even simultaneously, I and several of my colleagues here at ESRI, we love teaching and learning. So we teach at different community colleges, tribal colleges, technical colleges, universities, and I do the same thing while I'm serving as my role at ESRI on the education team. Now, My definition of spatial thinking and why this all matters is identifying, analyzing, and understanding the location, scale, patterns, and trends of the geographic, space, and temporal time relationships among data, phenomena, and issues. Now, it's not just me saying this. The National Research Council published a report called Learning to Think Spatially, which made a strong case, I believe, for the value of spatial thinking throughout the educational system. My own research is focused on the implementation and effectiveness of GIS as a teaching and instructional tool. And I also focus on serving and analyzing, being critical of data. So, for example, I love the Living Atlas of the World that Dan shared. As I mentioned, I serve on the education program here at ESRI, the goal of which is to encourage deeper and wider implementation and application of spatial thinking through GIS so that students can become wiser decision makers once they graduate in society. So that is why we have been working since 1992 on this team in primary schools, secondary schools, libraries, universities, community colleges, tribal colleges, technical colleges, after-school programs, wherever education happens, to support the use of GIS throughout educators' lives and students' lives. Now, let's consider 5 converging forces that I submit to you all are important as you chart your own course forward using geotechnologies. First of all, geo-awareness. People are aware of issues that you and I in the AGU community have been talking about for years: climate, weather, natural hazards, energy, water, and so on. The general public is now aware of those issues at a level that they have not been, at least in terms of what I have been reflecting on in my career. And secondly, Geo Enablement. People have used the JHU coronavirus dashboard by the millions per hour. They have used a mapping app to navigate their way across campus or to the nearest public library. So they're enabled, at least in some ways, to use some of these tools that we're talking about right now. Thirdly, Dan referred to this, the web cloud-based advent of GIS is a huge leap forward. Sharing data, sharing methods, the community, that is a big leap forward for GIS. And it also, in terms of how it affects you all listening to this, means that it's much more accessible than it ever was before. And fourth, citizen science. Citizen science has been around for 150 years, but having those data points, lines, polygons, etc., data out in the field, quickly mapped and then analyzed to make wiser and smarter decisions is a big leap forward for citizen science. And finally, storytelling with maps. Maps have been used to tell stories for thousands of years, but we have multimedia interactive maps, for example, ArcGIS story maps that enable people to tell their story to a very wide audience. Now, I also like to have you consider these 5 trends that I believe are important as we move forward in this decade. 3D. We live in a 3D world, and it makes sense that we've got 3D analytics. We've had 3D visualization for a while, but only in the last few years have we had true 3D analytics, which again is important in our multidimensional world. Secondly, IoT, Internet of Things, and big data streams. So no longer do you have to go out and grab pieces of data that's still a valid workflow and move them into your GIS. You can increasingly access that data as a service, saving time and lots of other savings there as well, costs, staff, etc. Bim Cad Gis, so the merging, at least in part, of the interior versus exterior space mapping. So the GIS community and the building information management, computer-aided drafting, and design community. Enterprise GIS, what I mean by that is more people in an organization empowered to use geospatial technology, not just the few down the hall that are the mapping people. And then finally, the integration of artificial intelligence and machine learning with GIS is going to radically transform the volume and the quality of data. And that has implications for how you chart your own pathway forward. The most important spatial tool, though, yes, it's great to know how to buffer and to georeference and to geocode. But I submit to you all that the most important spatial tool is this tool right here, your brain. This is the one that you need to nurture. And again, I salute you for wanting to listen to this session today. The tools will change, the data will change, the way we serve data will change. But I encourage each of you listening to this to actively pursue spatial thinking through GIS and remote sensing and related geotechnologies.
Hey guys, so following up from Joseph, my name is Kathy Capelli, and I'm a product engineer on the Learn ArcGIS team. And I also act as the team's tech lead for Arcgis Online. So in my day-to-day job, I also do a lot of GIS work. I work across the platform with pretty much all different parts of the ArcGIS product. But I also administer the Learn ArcGIS organization, which is really similar to the trials, but more geared towards students and educators. During COVID, we also extended this access in 2 separate programs. So one was for students who had lost access to their campus GIS labs to help them finish up semester projects. And the other was for professionals who may have been furloughed due to COVID or were looking for new jobs and needed to take some Esri training or some of our own learning materials to brush up on their GIS skills or add some new courses to their resume. And it's funny that Joseph mentions this GHU dashboard, because one of the main things we saw created across both of these 2 programs was some variation of this dashboard. I mean, you've seen this everywhere now, right? In the news, on different social media platforms. And what we really struck by with this dashboard was that so many people found it necessary to understand the pandemic. So this version is obviously a lot more robust than what we saw in the beginning stages of the pandemic back in the spring. Now we have data at several different administrative levels, from the county all the way up to different countries. We have a lot more metrics than we did before as reporting gets better. And this is also a lot more interactive. So we can click and zoom around the map. And the reason that people did this was so that they could start to understand the science of epidemiology and how it would affect them, their loved ones, and their communities. And that's one of the reasons I really love GIS, is I see it as a bridge between the sciences and humanity. So one of my primary aspects is the human aspect of climate change. And for that, I want to show you guys another one of the lessons that my team puts together. So this is one of hundreds of resources that we publish. And this is one of our scenario-based lessons. And all of the stuff we do uses real-world data to solve real-world problems. So as I said, this one's about climate change. And we really want to help people understand climate projections, which you guys are probably pretty familiar with, but a lot of people don't know the difference between some of the various projections that are out there. So in this particular lesson, we use ArcGIS Pro here to look at projections. And this happens to be just our baseline data. So this shows temperature and precipitation from the period between 1986 and 2005. Here you can see our mean values with the hottest bands, unsurprisingly, around the equator. So some of the ways that we can really help people drill down into this data are with ArcGIS Pro's charting. So this is a 1 meter raster grid. And to show you this chart, I've actually created an XY layer, which is basically just points for each of those grids. And I've charted it by the relationship with latitude. And to really show you what I'm doing here, I can select these top points with the highest mean temperature and show you exactly where those are occurring. Likewise, I can do so with the colder temperatures and even get really far down into the polar latitudes here. So then to compare this kind of data to one of our climate projections, so this is RZP 8.5, and specifically for 2020 now to 2039. So I've already added this NetCDF layer to my map, and up here you can see where the greatest change is projected to happen. So I've already showed you our charting tools and 2 NetCDF files, but if I wanted to do this for multiple, I could actually script that out really easily. So I've already run these as individual geoprocessing tools, but what I can do with our new hosted notebooks is go to my catalog pane and add a brand new, here we go, add a brand new Jupyter notebook. So this is going to open up a blank notebook where I can import ArcPy, if you guys are familiar with using some of the ArcPy tools. And I can also pull my individual geoprocessing tools into the notebook using the copy Python command. And then I can script this out so I can pull all different NetCDF files from that same directory and map multiple at one time. So that's just one example of the power of maps that you can use now to really bring your analysis home to people who need to understand kind of the overview of it. And one of the reasons that we do that is the Living Atlas of the World, which I think both of my colleagues mentioned, publishes these kinds of indicators. So this is a really high-level overview of that same data that we're helping people understand. Here we have global temperatures. And as soon as this loads, it is a really accessible map view of that same data we just looked at. This is really putting GIS into people's hands in a way that they can interact with and understand. So the next thing I have to show you is our Learn ArcGIS site, where there's a ton of materials that you can use to integrate any of these workflows into your current scientific workflows. So we have a lot of tools that are starting to integrate Python and R with hosted notebooks and our R ArcGIS bridge. So here is our data scientist persona, where we have a lot of spatial analysis lessons and tools that you can start using today. And up here, if you want to join our Learn ArcGIS platform, you can get free software access as well. This is also starting to build out into different curriculums. So if you're a professor or anyone working at the university level, or even if you just want to teach yourself, we have an entire curriculum around imagery and remote sensing that will be launching next week. It starts from the very basics, getting to know imagery, and it moves all the way up to doing spatial analysis, working with 3D and multidimensional, and then publishing those results so people can understand what you're getting at.
Well, thank you, Kathy. That was awesome, and Joseph. So I think what we wanted to do is take some time in almost a panel way to throw some questions around, because obviously we have very different backgrounds and experiences with GIS. And so to bring a couple different perspectives about how you might be able to integrate GIS into your career, either as you're still going through your education or as you're going through your early career development. And so I'm going to ask Joseph this question, and that would be, if you're a student or a professional who's just getting into GIS, what do you think are the 5 most important skills that they need to develop?
Yeah, good question. Thanks for posing that. We'd love to have a further discussion with you all listening to this, but I would say first and foremost, being curious about the world, about your community, about the world is the most important skill. We at ESRI and other organizations, they're wanting employees that are very curious about how to get things to work, not just in software, but why doesn't this work in my community or in my eco-region or in my region of the world? So ask questions that your professor, if you're students, ask questions that your professor's not even asking you. Think beyond what your professor's asking you. If you're an employee, ask questions that your employer is not even asking you. Because for example, we don't want just folks that know GIS, but people can ask, well, why are we pushing these buttons instead of those buttons? And do we need some buttons and tools that we don't have right now? And if so, how do we develop those? So I would say that's the most important one, Dan. I'd also say that knowing your geospatial foundations is important. Now, you heard me talk about how it's great to have people in business and engineering and city planning and other disciplines using geospatial. And I like that. But I submit that there's a few people in society that need to know a lot about GIS, including you scientists out there. And there's a lot of people, I would argue everyone, needs to know a little bit about GIS. So there's that sort of pyramid. The foundations are important, how to set up a geodatabase and how to symbolize and how to classify and how to do spatial analysis. All that actually matters because of what my colleagues have been touching on here today, and that is that your maps and your data is not just in the old days of your own desktop GIS, right? It is for the world potentially to see the results. So you need to be cautious and thoughtful about how you create the kinds of things. For example, Kathy was showing the JHU coronavirus dashboard, how people are actually interpreting that. Third, I would say being able to work with data and being critical of mapped data and all data, but where did that data come from? Can I trust it? How do I assess its quality? And that's another reason why I like the Living Atlas. It's full of metadata, rich and deep metadata. I would say also, fourth, embracing change. So go outside your own disciplinary comfort zone. If you're in a conference, go to a track that's totally outside of your own wheelhouse. Go international, go outside of your regional comfort zone. And then last, communication skills, I think, are very important going forward. Having that elevator speech down, your 30-second speech, your 1-minute speech, your 5-minute with your board of directors, your city manager, your CEO, your scientific colleagues, et cetera. Your half hour, your 2-day, et cetera. Have that elevator speech down. Those, I would say, would be the 5 most important. And, we can have a debate and discussion, and they may change, but those bubble to the top 5 for me.
Your point about the elevator speech is perfect. I think that people should have their 30-second GIS, their GIS elevator or elevator GIS, because it's amazing what you can do with your career by being able to show your boss or something like how quickly you were able to do this, and get this answered. And it's the GIS of getting in the elevator and having that pitch and that ability to communicate. And I think that we're finding as more and more of these tools become more powerful and easier to use, that's becoming something that we can all have in the back of our pocket.
And I don't know about you, but I have to give that elevator pitch every year at Thanksgiving with my family. So.
That's true. They say if you can communicate what you're doing effectively to your own family members, that is sometimes the hardest audience of all. Good point.
The one thing I wanted to ask both of you is, we talked a lot about, the resources that are available. Kathy especially touched on some of the learning things. Can you help to kind of tease out where all these things are and how people can kind of find them? Because I think there is. I will say, the one thing that I found that was really interesting when I was at NOAA and again, trying to get interested in that GIS was like all of the support that's there, that's available, as opposed to when we were working with some other platforms that were not supported. They were open source, and, you might have a little bit of here and a little bit of documentation there, but can you touch on how much and where it is?
Yeah. So like I said, I work on the Learn ArcGIS team, and what we really want to do is kind of provide you that first look. So how does GIS interact specifically with a topic you're interested in? And I can put these links into the chat. We can put them up later. But from our materials, we really want you to move up to Esri training. And what that is a broader look at the platform. They're really teaching you, like Joseph trying to hit home, the foundations of GIS, really those basics that just go across the entire platform and will help you with any aspect of GIS you're trying to do. Joseph and I are also big fans of the MOOCs, which, Joseph, you want to talk a little bit more about. Those are amazing also as introductions to GIS.
Oh, sure. Yeah, we could go on, folks, but the massive open online courses, I love those. They have personality, so the people teaching them are very passionate and they're lively and engaging. We've got about, Kathy, 8 or so in the set. Earth imagery, how to create geo apps, location analytics, so more of a business focus, spatial analysis, and others. But they're offered at certain times of the year. So they're not just posted, unlike the training resource that Kathy was talking about. Those training resources, by and large, you can go through those at any time. But the MOOCs are designed so that, touching on what Dan was saying, you're building community. You're networking as you're going forward, kind of like a university online course in a sense, but they're free. They're 6 weeks long. And they're not meant to compete with university courses because there are many, many good university GIS certificate programs, degree programs, et cetera, that we'd love you to tap into as well. But these are meant to supplement what you're getting at the university courses. So thanks, Kathy. Yeah, I love those MOOCs. And folks, feel free to tap in. We all take the MOOCs as well because we're like you. We're still learning.
Yeah. I will say, from having typically been at the AGU booth for Esri and working and taking questions from all of the attendees, one of the things that I wanted to point out, one is everybody comes over and is interested in maybe learning one thing. And then I'm always able to pull up learn.arcgis.com and say, oh, we have something there that you can learn how to do this part of GIS. The other thing that Joseph made a point of is that these things can be great supplements to what you're getting in your formal academic coursework. And not just as here's an activity, but one thing that I've seen is maybe your professor is using ArcMap, which is our older version of desktop software as opposed to ArcGIS Pro, which has so many more bells and whistles, way more performance to it. It does thousands of things that you can't do in the older platform. That if you're not getting the learning experience from your professor that you want to get, there are those resources in learn.arcgis.com that can get you either transition from the one platform to the other, or give you those, all those different lessons and opportunities. That's how I learned GIS, by going to learn.arcgis.com. It's done amazing things.
That just makes my heart happy.
I do nothing.
You got this interesting perspective that because you were a scientist, and then you didn't abandon your science, and that's what I think is a powerful message for people. In the not too distant past, and folks, we won't bore you with all kinds of details here, but it was here. Take this set of manuals, and now you go learn GIS. And oh, by the way, you're going to have to put your career as an oceanographer or a city planner or any other profession sort of on hold, or at least set it aside for a while, because there was just such a steep learning curve. But Dan, I think you're a great example of you still are very keenly tied to atmosphere, oceans, weather, climate, data, and analysis, but you also had that GIS. And so I was wondering, what was it like for you to sort of get into the GIS community? Have you ever met anybody that was like, I won't share any, my wisdom with you? Or was it quite the reverse?
Oh, it was totally the reverse. Especially, I found when I was at NOAA, and there was, the individual people that you referred to sitting, one part of the hallway, they were always ready to help you if you needed some kind of analysis, because they knew that they held the key to the box, right? That they could do something amazing with. And then when I got to Esri, it's amazing how many people were just, I felt like an idiot because I didn't know how to do basic things. And they were always, patient and willing to work with me on them. And I think that just says something about the community. We're all interested in answering questions. We are just doing it with different tools, and the questions are a little bit different. But we have this one thing that kind of brings us together, and that's our love for thinking geospatially.
Okay, so then I have a question for Dan. What would you say the top ways are that GIS has evolved to support climate risk analysis?
Oh, that's awesome. Typically GIS isn't thought of as a go-to platform for analyzing anything with weather or climate, and that's again, that was your father's GIS kind of thing. We've really been evolving the platform to be able to handle all sorts of, not just the formats of data and the types of data that you would use for a climate analysis, but the types of statistical analyses that you would want to do with it. So one, the biggest things would be multi-dimensional analysis and ready-to-use tools. I'm going to actually share my screen for this. Here. And we can see here, I just brought in a NetCDF of GPCP, the Global Precipitation Climatology Project. And it's a multi-dimensional data layer. It has time. We can see here from 1979 until, whenever I downloaded it was. But one thing that happens is because it reads that this is multi-dimensional, an entire ribbon of capabilities pop up here in ArcGIS Pro, where we can aggregate the data into different time steps. We can run an anomaly instantaneously across this layer. We can use trend analysis, zonal statistics, all of these things, summary statistics. We can run profiles and do some of the graphing, but do it through time, like what Kathy was showing earlier. And these are all just built in right now that you can do it in a matter of clicks. There's also some really cool things where I brought in Landsat data, which is coming from Living Atlas live into the platform. And by running some of our raster analytics, I was able to identify urban heat islands in a spatial analysis, not in a temporal analysis where you might say, looking compared to the last 30 years, I'm saying compare block to block here. What blocks are hotter than others? So we're thinking spatially. So that's one thing, the integration of multidimensional data into the platform. Two would be notebooks. And Kathy showed a little bit about that earlier, either notebooks here in ArcGIS Pro or hosted in ArcGIS Online. So if you've used Jupyter Notebooks or any kind of Python notebooks, you can now develop those in a hosted online environment and share and collaborate. The awesome thing with that is you don't just use like where Kathy did import ArcPy. You can import SciPy, NumPy, TensorFlow, any of those libraries that you want into the platform. It's going to make those connections. We are trying to make sure that you can bring ArcGIS to the environment that you work in and not force yourself to use our platform. So you would never even have to learn how to use ArcGIS Pro. What you're seeing here, you could do everything that you can do in ArcGIS Pro can be scripted out in command line style in Python. So that's really awesome. Three is big data connections. So I can insert a new data connection to an AWS or Azure or anything like that. So I can tap directly into a big data store, and it's going to act like it's a local drive on my computer. Drag those files in, now run your spatial analysis that way. And we also have things like our big data connection where you can map to thousands of CSV files and never have to merge them all together. So if you're looking at big climate data analyses, like you sometimes get from NOAA and CEI, and each year or each month is a different CSV, this platform will now see them as one single file. And you never have to do anything beyond that. The last thing that I would say would be some of the more sophisticated modeling capabilities. EBK or Imperial Bayesian kriging has been a huge upgrade to this platform. We use that for a lot of climate downscaling, and the incorporation of other machine learnings is really allowing you to do some really advanced climate analysis in the platform. So it really has me excited about that. I would pitch it back to Kathy though and ask, so we have this great climate science or analysis. How can we intersect that with some of the human demographic information that we have in the platform? Because GIS isn't just about the Earth and the Earth science; it's also about being able to bring in the human component. So how can we get to that human impact aspect of it from here?
Sure, Dan. And you're showing Pro right now. Let me jump over into Arcgis Online where we have a few more examples. So here we have a map that's really similar to what Dan and I were working with in ArcGIS Pro, right? So we're looking at the same climate model, but about 10 years into the future. So here we have, we can add those different country boundaries here. And we're going to look at Canada because, as we can see, the northern parts of Canada are going to be pretty strongly affected in this model. And what we can do is, with a few clicks, we can look through all the data variables that Esri has for Canada. So we can find different vulnerable populations, the projections for the future, and how we can possibly help these people. So we can look at age with lots of different variables here projected out until 2025. We can look at income to see what kind of people are going to be able to adapt to some of these changes. And again, projected out into the future. And we can apply all these variables. I'm not going to apply 38 because it'll take a little bit of time to run, but I can show you this map here, which has already been done with all of these variables. And as you can see, we have a bivariate map where we're comparing the future climate and precipitation to the different cities that are currently on the map And the bubbles here are shown by population, as well as that bivariate change. So Toronto and New York are going to be a lot warmer and wetter than in the past, whereas other places, especially in the Mideast and in Europe, are going to be sort of colder and drier, or warmer and drier, sorry, than before. So you can see these changes across the map here, and how they're going to affect people in all of these cities.
Awesome. That really does bring it home. And a lot of us, having that easy part of the platform that just lets you say, add it in. I don't really know where population data exists, or the formats for it. I know climate data or other, big earth science data. But, if it's just that easy, it allows a lot of us to be able to make that connection. Thank you, everyone. I think that's going to end our panel discussion. And next, we're going to have opportunity for you to ask us questions. We look forward to your questions. Thank you.
All right, so now it is time for our question and answer section. And we have one question from Emily, and that is, can you link individual images from social media to get real-time visual social analysis? And I'm not too sure where you're going with that question. Maybe you can clarify that one in a little bit more detail, and we can try to get that one answered. You'll see that in the chat section, we've been linking to some of the resources that were discussed during the presentation. So things for the Learn lessons, things for Living Atlas, the MOOCs, and other resources that you might find useful if you're interested in either starting to learn how to apply GIS or continuing your pathway in incorporating more GIS into your analysis. So there's a question about whether there will be a recording of the whole segment. I would have to defer to any of the AGU staff that might be monitoring this. Maybe they can answer one of the questions or include it in the chat. Emily, I think you're you definitely have a complex question here. I'm gonna put my email in the chat, and I encourage anybody that's interested in learning more after this that you can reach out to me directly. So thepursuit@esri.com, and maybe we can follow up on your question after this session. All right, it looks like a recording of the session will be available on demand shortly after this session concludes. So make sure you share this with your other AGU friends that might be interested, or colleagues in learning what we've talked about today during the session. Or you can just keep watching me over and over again. I'm sure that would be a lot of fun. So Dean asked a question, where can we find GIS resources for secondary ed, like earth science, environmental science? In the learn.arcgis.com website, there's actually a section at the top that says for teachers. So if you are a secondary ed teacher in earth sciences, you can start to browse those different things. I should mention that all K-12 classrooms have full access to ArcGIS. So you'll definitely want to take advantage of that. Through the ArcGIS website, you can find the links to get licenses for your schools. And actually right now, through Learn, we actually have free access to anyone as we're going through this pandemic to the ArcGIS platform. So if you're interested in getting licenses for Pro or ArcGIS Online or any of the software, we have dozens of different software products to do different tasks. You can access all of that, and then also the training to learn how to use it through the Learn website. So I encourage anybody interested to go to that learn.arcgis.com website, find those resources, find the free access if you don't already have it. Most federal agencies, they have it. In the U.S., they have access. Most universities, they have licensing. It's sometimes just trying to find the person at your university who might know how to dole out those licenses, but it's pretty common. So Noel, my colleague, has been posting more of those links into the chat. She's pretty quick with these things. Noel, maybe you could find the link directly for the free information, or the free to register for a free ArcGIS license. Actually, I found it right here, so I will be able to post that into the chat. We have another question. How is learning for instance of program language like R or Python translate to GIS learning? Is there a through line? Is there any kind of capability? So everything, Python is the back end of ArcGIS, at least our platform. So whether it's Pro, anything that you can do, you can script in Python, and some people choose just to do the scripting. I know one person that was on my team at NOAA. He's still there. He doesn't even touch the desktop software. He just scripts everything in ArcPy. ArcPy is ArcGIS Python, and then so you have that. So you can either work in your Jupyter notebooks, or you can use whatever kind of shell program that you want. There's the question about R. ArcGIS has a linkage to R, so we call that the R bridge. So you could bring your data in to the ArcGIS platform, whether it is in a notebook or in the desktop software, You can make your connection to R in just configuring the settings of this of the platform, and then you can run all your analysis using R, and then kind of ship those results back out and map and visualize, and use the ArcGIS platform to tackle some of those really complex visualization tasks that you may not be able to do in R, and kind of do the leverage the best of both worlds. So yes, you can definitely use R and Python. I would also say that we have entire APIs for Python. So there's the Python API for ArcGIS. If you're a developer in web, there's the JavaScript API. So through these things, you can connect to the data and then go down different development paths that are pretty powerful. Again, you search the Esri website, and you can learn more about all these different types of products. What are the options if we want to develop a model in Linux? So ArcGIS Pro, our desktop software, is Windows only. I think one of the great things is, so you have the option to install a VM, or launch a VM and install Windows on that and install your desktop software. That's pretty common. We do that a lot in especially in the federal space where most servers are Linux based. I've seen that, and then a nice if you have that VM sitting on a server somewhere, you can make a remote connection into that. So ArcGIS Pro allows for a remote connection, so you could actually be on a Mac, log into your remote environment, and then you would use your browser to run everything that you would see as if that software was sitting on your computer. So that's one way you could get around it. Then, of course, the other would be to use notebooks if you're running, or if you're a Python person, that you could use the Jupyter notebooks in your Linux environment, whether it's any flavor of Linux or Mac, and take advantage of all the capabilities just through the Python notebooks. Awesome. Noel just posted the developer's guide for Python and Jupyter notebooks, if you're interested in learning more about that. Again, the nice thing, as I was saying before, you can run Jupyter notebooks locally on your computer or in a cloud-hosted environment through ArcGIS Online. If you do that, you can share those notebooks that you're working on collaboratively with other people within your ArcGIS Online organization. So you can really start to as it moves us away from, I'm going to do my work right here on my desktop, on my local computer. Now we're collaborating on these individual notebooks or sharing the results of them across your organization. And then you can share them publicly. So if you have, let's say you are publishing your science, or you're presenting your results here at AGU or wherever, you could put a link into a publicly shared version of your Jupyter notebook through ArcGIS Online, and anybody would be able to be able to read that. definitely some great questions that are coming in. Keep putting your questions into the chat or in the Q&A section, and we're happy to answer them or provide some links out for more resources. I should also say that throughout the 2 weeks of AGU, we, myself, Noel, and many others, other subject matter experts from a wide variety of backgrounds, will be available in the Expo Center. So you can always chat with us there. Just go to the Esri booth in the Expo. I know that Joseph will be available if you are in education, formal ed or higher ed. He's a really great resource for tapping into if you have questions, or if you have questions about licensing as well. We'll have people available in our expo to figure out, does your organization already have access? And so you don't have to go through applying for one of those short-term free software packages. So it looks like we have just 4 more minutes, and then we'll be closing out this session. So if you have any last questions, please pop those in. Otherwise, this was a lot of fun. I hope you enjoyed it and got some really great information from Joseph, Kathy, and I, and then also Noelle with her quick links that are going all throughout the chat. So make sure you copy some of those things down, and then, like I said, we're happy to answer any other questions at the Esri booth. I hope you have an enjoyable AGU, and yeah, I can't wait to go learn about what all of you are working on as well. All right, with that, I think we're going to close this session down. So thank you, everybody, again, and I look forward to talking to you later. Thank you. Goodbye.